Uh, so, Hello, good evening, everyone. Thank you for joining with us. Today, we are having the third session of the AWS DevOps webinar series, which will be about logging and monitoring serverless applications. So, if you were not able to participate in the previous two sessions, we will put the link of the YouTube playlist for this webinar series in the chat so that you could go through it after this session. So if you have any questions during the session, you can post it in the chat and we will take it up during the Q&A session. And our speaker for today's session will be Manoj Fernando. So just to give an introduction about him, he's an AWS certified solutions architect and a technical architect at 99X with over 8 years of experience in the industry. He's the founder of Enlia Cloud Trainer Academy and co-organizer of AWS user group Colombo. So I would like to invite him to continue the session.
Thanks, Vihanga. Thanks for the introduction. Yeah, hi guys. Good evening or good afternoon still. Yeah. So let me first start sharing my screen. Hope you guys can see my screen first. Are you guys able to see my screen?
Yes, we can see that.
All right, great. All right, guys. So as Vihanga mentioned, this is the third part of the DevOps series. And in the first two parts, I think you have got a very good understanding about what DevOps is, the introduction to DevOps, and also how DevOps can be implemented, the CI/CD pipelines using AWS platform, particularly in AWS platform. So I would like to take it the next step of the DevOps life cycle, which is logging and monitoring. Now, so this session is mainly mostly hands-on, so that usually loggings and monitoring stuff are a little bit boring. So I thought of like getting my sessions around these hands-on demos, so everyone can follow along. And also, if you guys have any questions, feel free to ask them towards the end. Yeah. So this is the agenda, guys. So first, let's see why logging and monitoring is important. And also then we'll directly jump into the 7 steps that I'm planning to cover today. So in these 7 steps, guys, I'm planning to create a serverless API from scratch. And then little by little, we are going to introduce logging and also monitoring into this application. And then we'll see different challenges that we come across. And also how we can tackle them with different AWS services as well as some third-party tools and services as well. So this is the agenda. So we'll first start setting up the API, and then I'll give a quick introduction to the application because that will be the application we'll be discussing throughout this hour, I believe. And then we'll talk about how we can do basic login and how we can do custom logins and subscription filters, metric filters, and real-time log streaming and real-time notifications, how we can accomplish these things in our serverless APIs and also serverless applications, really. And then we'll talk about the importance of centralized log management and visualization. And I'm planning to use a third-party tool or service called logs.io. And then we'll talk about one of the really cool service, which is called Amazon DevOps Guru, which is a recently announced service. And I find it very fascinating. So I thought of discussing about that towards the end as well. Okay, so let's get started, guys. So step 0. So why logging and monitoring is important? Because without knowing that, there's no point of really going into other steps. Now, in the previous 2 sessions, you guys learned about DevOps, right? What DevOps is a culture. I think that we all now understand. And DevOps actually has different, this loop, I would say. So we'll start with, let's say, if it's a newly creating product, we plan and we'll start coding, we build it, and after testing, we go ahead and release it, right? And so when it comes to this part of this loop, all these constructs or the CI/CD, continuous integrations, and continuous delivery. Continuous integrations happens at this stage, right? And then you release it with continuous delivery. So there we use CI/CD pipelines. I think in the previous sessions, you guys had a very good understanding about how we can release it with automatically using AWS Beanstalk, I believe. And so that all covers this part, guys. So after that, what happens is we'll be releasing our application, the production application, into the internet. The internet is the wild. So there are a lot of things can happen to our application. So that's why we need to constantly monitor our application and then take promptive action if there are any errors occurring. And also, our applications is vulnerable to all these internet attacks and all these internet vulnerabilities. So we have to make sure our application is protected against those. So that's why the monitoring really plays a large part. But monitoring alone can't do that. We need to have a proper logging. So logging complements your monitoring system. If you have a very good logging system, then you will, of course, can have a very good monitoring system as well. So these two are logging and monitoring are kind of complementary. So one complements the other. So after that, when you have continuous monitoring setup for your application, then you can get those feedback from those monitoring system back into your planning. So it could be some performance optimization, some production errors or production bugs that comes through these monitoring systems, and then you can start directly integrating those changes into your application and keep improving your application. So that's why this is a never-ending loop, guys. So every time you do a release, you monitor it with the logs and all that, and then you get the feedback. So this is the DevOps feedback loop, and then with those feedback, you continuously innovate, continuously improve your application. So as I previously mentioned, it's an integral part because that part is always there in the DevOps cycle. And usually we sometimes tends to neglect this part. We stop it at the CI/CD part. So once our application is delivered to the outside world, probably we'll wait if one of our customers found out a bug and complains about it, right? Probably, our customers come with the issues and maybe some improvements that we can actually add it to our applications. So then only we take actions, guys. So this is kind of a reactive way of improving your applications. What would be a good way is a proactive improvement. So you should really understand what are the bottlenecks and what are the bugs that comes up with the new releases even before customers start using the applications. So that's where really monitoring and logging shines. So with a proper monitoring and logging setup, you can understand, you can identify your production bugs, issues very early stage, even before customers start using it, and you can take promptive actions. Because when you do that, that really improves the user experience. Because if your users really find out different bugs, while they're using your application, that really hinders the user experience, right? So that's not a good thing. And probably since today it's a very competitive world, they probably opt into a different product, right? They will get rid of your product and maybe opt into a new product. So that's why we need to make sure users are satisfied and their experience is at the optimal level. So it improves the user experience, of course, and then it could save financial losses. For example, let's imagine, if Amazon downs for a couple of minutes, how much loss they incur, right? So these things can be identified before happening, right? And then take promptive actions through a proper monitoring and logging system. And of course, it's going to promote continuous improvement. And these are some of the reasons why you really should have monitoring and logging implemented in your applications. All right, so I think with that, I can segue into our step one, because as I previously mentioned, it's always good to start with the hands-on so that everyone can follow through with the example. We find it easy to understand through examples always. So the example that I'm going to talk about today is, guys, a serverless API. It's a very simple serverless API, and I think most of you are familiar with AWS services, I believe. If not, that's fine, because we don't use much AWS services in this presentation. So what I have here is a simple diagram about the step one. So our application has a API. So in AWS, we have this API gateway. So this is our gateway to our application services. So our users can consume our API. So in this case, our API is a public API, and that is going to send us Fibonacci sequence. Let's say if someone wants to get the Fibonacci number, the sequence value for a certain number, they can, say, okay, give me the fifth Fibonacci number. So they can use this URL pattern /generate/5, and then our API gateway forward it to our backend services. And then in our backend service, it will return the fifth Fibonacci number. So likewise, they can always request for more Fibonacci numbers. And so our backend is basically a Fibonacci generator, guys. So when it comes to backend, this is a serverless backend. So why I said serverless is we are not using any servers or containers right now. And this is a serverless function. So the serverless function in AWS is called AWS Lambda. And this is the AWS Lambda function. Though these are not long running services, they will invoke by certain events. So in this case, they get invoked by this HTTP event, and then they will execute that code, return the response, and then they go down. And these lambda functions are controlled by this AWS Lambda service in AWS, really. So sometimes people confuse the Lambda service with Lambda functions. So that's why I added it separately outside, just to say that there is this AWS Lambda service that controls all these Lambda functions. So this is a very simple thing, a very simple architecture, I would say. So let's quickly go into our application. Now, before going into the code, I added all this code into this GitHub repository DevOps session. I'll put the link once this presentation is completed. And I added all these steps in branches, right? So step 1, step 2, step 3 through step 7. So you guys can get the code and then try out even after this, and let me know if you guys have any issues. So right now I have cloned that repository. So right now, where am I? I'm at Git branch. So I'm at step number 1. Right? So here what I have is a serverless.yaml file. Now, in order to create this application, I'm using serverless framework. Now, if you guys are not familiar about serverless framework, so this is a link to their documentation. Now, there are various frameworks out there to create serverless applications. And of course, you can just use AWS console to type your Lambda function code, and by hand you can do all this. But it is not recommended. You always need to have some proper frameworks that supports code reusability and infrastructure as code. And I think maybe the next session you guys will learn about infrastructure as code, how we can version control our infrastructure alongside with our application code. So this framework is very popular in AWS and also in other frameworks and other cloud providers as well. So I'm at this AWS section, guys. So in order to use that, I need to install this serverless CLI globally, which I have already done that. And then it's all starting with creating a serverless service. So if I go to this serverless services section, there's a simple command to create a serverless service at the creation stage. We can create a serverless service based off of a template. So there are various templates. So I have used AWS Node.js service, and you can use Python, Ruby, and Java, C#, and whatever the template that you are familiar with. And I just use AWS Node.js because I'm more familiar with that. And then once I did that, I get this serverless YAML file, very basic configuration. And also I get another file. This is the handler.js file. Now the configuration file, guys, it's always containing all the configuration for our Lambda functions. Now in the previous slides I showed you, we have a Lambda function as well as an API gateway. So, in a couple of lines of code, serverless framework is able to create our API gateway and link it with a Lambda function. How it's going to do that is that we have to declare these function blocks and then give a name to this kind of a logical name to this Lambda function. And then I can point out where my Lambda function code is. Right now it is in handler.generate. Handler file is this one. And if I open this up, so this is that Lambda function code. Right now it is nothing. It's just returning hello from fib generator. That's all. And then I have defined these events. So I previously told like these Lambda functions get triggered based off of events. Right now I'm using this HTTP event, and it's not only HTTP event, it could be different other types of event that these Lambda functions can trigger. So, but let's use HTTP because we want our users to use HTTP to invoke our services. So with these couple of lines of code, guys, we get the API gateway, and it's going to create this path pattern / generate. So this path pattern, and also it's going to link that path pattern to our Lambda code. So it's going to invoke this particular code. So how we can verify that? So we can easily go ahead and do Sls deploy. I would have actually done that prior to my explanation. It's not going to take a lot of time, but it will take a few 30 seconds or so. So this is going to do basically create the infrastructure as CloudFormation template. In AWS, guys, all these services that AWS provides can be spin up using some configuration types called CloudFormation. Now it's already deployed. If I just open up those .serverless file, I can see that CloudFormation templates. Now, do you see this CloudFormation create stack and CloudFormation update stack? These are nothing but some JSON configuration file. You can see it's a long JSON configuration file, and it's going to configure all the AWS, all that AWS API gateway and the Lambda functions. And we don't have, if we don't use the serverless framework, we have to type all these things. But serverless framework abstract that everything. So we just have to write only these commands, and it's going to convert it to CloudFormation. And this once we have deployed it properly, it's going to give us the API gateway endpoint, which we can test. So if I just open it in a browser, I should see that hello from fib generator, which is the return message from our Lambda function, which is cool. So that is our first step, guys. Now, as for our second step, I'll keep this screen open because I think it's easier. As for our second step, guys, I'll introduce the application. So let me quickly jump into the second tab, second branch, really. Just reset it. Check out step 2. Okay. Now this file has introduced, actually this the new code has introduced 2 changes. Previously it was only generate. Now I added this a number as a dynamic value. So I'm like passing this as a variable because people should be able to add any number and then get the corresponding Fibonacci value. And on the code, I actually added the code to generate the Fibonacci. So this is the generate function. So it's basically I'm picking the number that the user enters, and then I will pass the integer value of it, and then I will get that number that the user added to the path parameter, and call this Fibonacci function. So this Fibonacci function is a recursive function, as you can see. So the number that you enter, let's say you add number 5, then it starts generating the Fibonacci number. If it is less than 1, the Fibonacci itself is that number. Otherwise, it's going to recursively call this function. I'm not going to like go ahead with the math behind it. So it's a very simple, I think all of you know about it. And finally, once you got the output, I will just print it out. So again, I forgot to do the deployment while I was talking, but let me do a Sls Deploy. So this should allow me to type the number and then that should return me the corresponding Fibonacci value. So let's give it a second. So in the meantime, guys, I'll talk about the other configuration that it has. You know, the runtime is Node.js 12.x. So our Lambda functions runtime is 12.x right now. You can use other runtimes as well. And also this is a service name, and all our Lambda functions belongs to this service. So let's give it a couple of seconds, and once it is updated, we can quickly test it. Let me know if you guys have any issues with the font size. If I want to like increase it a little bit more. I hope this theme is also like clear to you all.
Yeah, I think it's clear.
Yeah, great. So let's give it 2 more seconds. Yeah, it's done. And that should print out the you know, the path pattern as well. But this time, instead of clicking onto it, just copy this one. Actually, the same thing. It has to add the number underneath it. So I'll first check. Let's say what's the Fibonacci first value. So it's the same number, right? So I'll just try the 10th one. So the result is 55, and I will just, let's say, increase it little by little, 15. So that's the 610, the corresponding Fibonacci value. I'll now do 20, and it's, you know, it is increasing. The complexity is increasing. I think this is complexity of big O n. I can't remember really. But however, when the number grows, the complexity increases. For example, if I do 40, you can see it is taking a little bit more time to compute the result and finally give the result. But if I do more than 30, 40, let's say 45, so it's keep trying to calculate that value. And the default Lambda has a timeout, and the timeout got hit, and then I got an internal server. So these are some of these you know, things that we need to handle it in the Lambda function itself. Probably like we should not allow our users to type more than 40, because I think the 40 is a edge, you know, that's the most number, highest number that that our Lambda functions can cater within the default timeout. We can of course increase the timeout, but we'll keep the default timeout for this demo. So this is our application, guys. So let's move on to our next step. So in the next step, this is where I'm going to introduce some logging part. So let's set up some basic logins, guys. So in order to add some logins, now we can use a console log. The console log, we all are familiar with that. If you do console log within a Lambda function, there's a direct integration with the CloudWatch. Now, CloudWatch is the Amazon centralized log management service, I would say. And when you do console log, it logs into CloudWatch. So let's go to our step number 3, and I'll do git checkout and reset some of these values, and I will check out to step number 3, and I will do Sls Deploy this time before I forget. Right. So in this case, it's the same function, but I have added some conditions. Right? So this is the generate function that you have earlier seen. So once I got the number, the passed number from the URL path, then I'll do some checks like whether this is the number really, because anyone can, let's say, add a string, let's say hello instead of 5 or 10. And then if you pass that the value would be not a number. So here in this check, I will check whether it's not a number. If it is not a number, then I'll throw that error. And also I'm checking, you know, if the number is greater than 40 otherwise, because our application is not supporting that just yet. So again, I'm saying number must be less than or equal to 40. So when I throw this, guys, I'm throwing this inside a try catch. So, you know, that ended up in the catch block, right? So in the catch block, I'm doing console log. So whatever the error that prints out. And also to the front end, I'm returning the error message. Since I'm using this new error object, there is this error message and the call stack, all these things get encapsulated. So always use like when you are doing try catch, throw new error without just throwing the string, throwing the string, because then it won't have that call stack or anything as such. So always do that so we can have additional information about the error. So let's see, check so it is properly deployed. So this time I'll use, let's say 10 with the, if it is working properly, the 10 works fine. So this time I will do 45. So now I get the error, number must be less than or equal to 40. Right? And if I do, let's say hello, we have a string value here, it's not a number. Now I get the return value here, which is fine, which is really what we expect through this. But at this stage, we console log it. So where can I see the log? As I previously mentioned, there's a direct integration with the CloudWatch. So I'm in my AWS console and I'll go to CloudWatch. And then, easiest way to find the logs for your Lambda function is maybe not directly going to the CloudWatch, but you can first go to your Lambda function, Lambda service really, and then search for your Lambda function. And through that, you can easily load the logs, corresponding logs in the CloudWatch. So I just opened the Lambda function, and I think our Lambda functions is this one. You see the fib generator, and it has added, a dev dash dev as well. So actually our name of the function is just generate, but it had prefixed with our service name and the stage. Now in any application, we have multiple stages. We have development stage, testing stage, production stage, and any more stage that we need. So here by default, it defaults to dev stage. So I'll open up this one. So this is that function with that prefix. So I'll open this function and then I can see the code in that function. Well, I can't really because this is too big, so it's not rendering here. But what I can see and what I can do instead is I can go to the monitor section and then I can view the logs in CloudWatch. So if I open that, then it is going to open the corresponding log group. Now, why I said it's a log group, every function that you deploy to AWS will create its own log group, right? So this is the log group of this particular function, fib generator, that generate function. And in this log group, we have different log streams. So it's not just one stream, but it's a multiple streams that it creates based on the time. And we can find the latest stream up here on the top really. Now, if I just open this up, I'll do a little bit of a refresh. Then I'm making sure the latest ones are loaded. And guys, one important thing I wanted to remind you is that the logging part of it, the AWS Lambda to CloudWatch logging happens asynchronously, which is a very important thing going forward in this presentation. So it happens asynchronously. So we are not waiting until the logs getting completed at this place, right? So once we do console log and error, we are not waiting here, right? We just return it right away. This happens asynchronously in the background. If we had to wait it, so you can see we are introducing another delay, which is bad for our application. So so our console logs, however, since this is asynchronously logging to CloudWatch, you don't have to wait. So it's one important thing we need to remember when we are using CloudWatch or any logging service. All these logs has to be asynchronous. Okay, so I'll go back to my CloudWatch and I'll open this latest log stream. Then I should be able to see the error. There we go. And I see the error. Hopefully you guys can see it. Error, the number must be less than or equal to 40. And I get the call stack as well. So the stack trace as well. That's why I told you like use new error without just throwing that string. Right? This is very important for our logging, for our monitoring and finding out where the problem is later down the road. So Yep. So I think now you guys have seen how the CloudWatch and Lambda integrates. So let's move on. So in step number 4, now we actually added some data into our log function, right? What have we added? So I'm still here. So we are just logging the error that we throw here. But usually guys, in our production application, just an error sometimes doesn't make sense. We need some more context about the error, right? Particularly if it is an error that is critical, and we all have this experience that we had to stay late night or early morning calls about the production issues. So at that time, and we are also fussy and sleepy, then it would be really nice to have some context about the error, so we can easily do a debugging and then put a patch or like a hot fix for that. So that's why we need to add some custom context into our log message, guys. So let me quickly switch to our other path. I think what is the branch I'm right now? Okay. Check out step number 4. Yes. And I'll do Sls Deploy. So it will happen while I'm talking. Yeah. So here, guys, so it is pretty much the same code, right? So we have these two logs, two, functions, basically, whether it's not a number or more than 40, and we are throwing as usual. But when it comes to logging, so I'm just using this log, and then instead of console log, I use logs. What is this logs? Nothing but just another custom logger function I just wrote it. So here, if I just go to this logger.js, so what I'm doing is I'm just getting the event and the payload into this particular function. I'm injecting the function context basically, because these requests are HTTP requests, right? And these requests kind of getting proxied from our API gateway to the Lambda function. So when API gateway proxy those requests to the Lambda function, it still has its path, HTTP method, and the source IP who actually originated this request, and also the stage. So I can easily get this from the context itself without having to inject anything additionally, right? So I'd like to use this context, but always you can add your custom data into your context, but make sure a few things. Now you all know that there's GDPR, right? So probably if you're logging customer emails and any maybe name, first name, maybe you have to anonymize or obfuscate those data, depending upon like if your citizens or the customers are from the European region. But there are like middlewares for Lambda, like MIDI middleware, which you can easily do that, but I'm not going to discuss on that today. That's yeah. But here always use some context about it. So when you see the logs in your log management system, it's very easy to understand. Now I'm injecting the payload as well. Let me show you how I am doing the log. So I'm passing the event, and then I'm passing what type of error is this. Like, is it a critical error? Because I can decide, right, whether if it is critical to my application business, or if it is just an information or a warning which I can come back to later. So in this case, I particularly said, okay, this is a critical issue. This is a user experience issue. So I treat it as a critical issue in this case, but this completely varies upon the business use case that you have. And also I added the message, the error message, and the call stack or the stack trace. So what happens is, I get the same data plus some additional data, the type of this error as well as the context. So let me see if it is, that is deployed. So I will go to my, this one, and I'll add, let's say 100. So this time it should generate an error because we don't support 100. So it returns me that error response. But this time, if I go to my CloudWatch to that generate function logs, I should see a new stream appearing. You can see now there are 4 streams, right? And if I just open up that stream, now I get more information. You see, I get the context. Now you see, now these are from the context, so I know what the user had typed in. It's a dev generate hundreds as a get request, and this is the source IP, this is the user IP, and we are on the dev stage, and this type is critical, and this is the message and the call stack. Now, this is some useful information, so which I can act upon really. Yeah, so I think that is the step number 4. So moving on to step number 5. So these were the interesting things we can do based on those data. So now I have some information, like I injected some data about path, payload, error stack. I can even do user agent, like, I know, because sometimes I'm not sure, like you guys might have faced this issue. Sometimes based on the user agent, let's say Firefox, Chrome, or mobile browsers, there are some platform specific issues, right? So those things can also be identified if you log the user agent and you have more context into it. So what happens is right now we have everything here. Now this CloudWatch service, guys, we can actually do more things with this. Now CloudWatch is usually the centralized log management service in AWS. But you see now at the middle of night, if I get a message like from my customer, okay, it's not working, I have to go all over these stack traces and find out where the issue is. Now this get really complicated very fast if you have a distributed application. Now if you have multiple Lambda functions, then as I previously mentioned, they are going to create their own log groups. So in order to find out, let's say you have one Lambda functions calling another Lambda function, or like other services that interoperate, then you have to like switch between these log groups, which is really a terrible task. So I need everything. First and foremost, I need get some alert. I don't want my customer to call me. So that's the first thing I'm going to do, right? So what I'm doing is in CloudWatch, there's something called metrics filters and subscription filters. Now, metric filters is all about I can identify some patterns in my log, right? And then let me see if I have deployed it. Where am I? Git branch. Okay, step number 4. Are we now? Sorry. Git checkout. Git checkout. Step number 5. Okay, and I'll do Sls Deploy. Okay. So what I was saying is now in subscription filter or metrics filter, we can filter out our logs, right? So we can filter out the logs based on the attributes that we have added into our log messages. Now, as you remember, we have added the type, right? So type is critical, and I added the stage. So stage is dev. So there is this some syntax which is very straightforward and we can easily understand. So in my subscription filter or a metrics filter, I can actually add some filters like this. So I want to filter out only the messages where the type is critical and also the stage is dev. Oh, it could be like for the most part stage is prod, because this is another very important thing. I previously mentioned, logging this asynchronously is very important. One really important thing to remember. The other thing is you should not stream these logs without any purpose, like just because you can, right? You have to make sure you are applying the proper filters, because if you stream these logs to other services without applying filters, then you're going to be in big trouble, because CloudWatch, even though the service itself is cheap, when it comes to data ingestion to other services, it's going to cost you quite a bit. I have some experience about some large bills when it comes to logs ingestion. So when you ingest a lot of payload into other services, then your AWS bill will skyrocket, right? So it's very important to filter out really important messages that interests you. So probably you might have to change the stage to prod. Your dev things, I think you can handle because it's not prod, right? But for this example, let's say it's dev. So what is the difference between subscription filter and a metrics filter? So if I just quickly go here, so my CloudWatch metrics filters is basically you can create some metrics. You can say, I don't want to inform my downstream services. I don't want to stream the logs from my CloudWatch as soon as some event appears here. Even though it is like say dev, it is a production stage and it is a critical type. I don't want to directly invoke that service, but I want to like let's say have a metrics on it. I would let's say wait until these type of logs get collected say 5 times within 5 minutes or 1 minute. If I get 5 of these messages in 5 minutes, then only I'm going to send that, right? So you can create a metrics, and then based on that metrics you can invoke the other services, which is a very good way of handling our ingestion to our third-party service, and we have very good control over it. Subscription field, on the other hand, it will like it will push these log messages to whatever the subscription that we added to CloudWatch. Now, in this case, I have added one of the subscription filter, which I'm going to delete it right now. So let me show you how to add a subscription filter. Now I can click create. Right now I'm in the the log group of our function, and I can create a subscription filter for Elasticsearch. Right, I can directly stream my log data to Elasticsearch that based on a filter, or Kinesis, which is the real-time log kind of analyzing service in AWS. Firehose, if you want to like say take the logs into low-cost destination like S3, you can use AWS Kinesis Firehose. But what I'm right now doing is I'm going to create a Lambda function, another Lambda function, which I can use to do whatever I want with the log data that is that I receive after a filtration. So that's where I'm going to click a Lambda subscription. And here also you can see the warning, the large amount of CloudWatch logs to other destination may result high usage charges, right? So this is a very important thing to remember, and you always have to make sure you are applying a proper filter. So that's why in the code itself, in the README file of that particular branch, I added this thing, and then let me add that filter. So I'm filtering the critical in the dev stage. So I can just say this is critical logs, which I must know beforehand. And the Lambda function, I have to show one more thing. In my serverless function, serverless configuration, earlier I had only one function. Now I have another function called dispatch logs, right? So the code of this dispatch log is in this dispatch.js. So let me just do this. So this is the handler function. So when CloudWatch dispatch this data to other services, it's going to base 64 encoding, and also it's going to what do you call the encrypt, not encrypt, GC compressed as well. So it GCP and then it base 64 on top of that. So in order to read that data, we first have to decode these things and and uncompress as well. So I'm using this library called zlib to do that, and finally I can view that data in this Lambda function. But one thing you should notice here is that this Lambda function is not getting invoked by HTTP event. It is purely getting invoked by AWS CloudWatch subscription filter. So that's why I haven't like added this event section, because if I add this event section, it's going to create an API gateway. And I'm not going to do that because that is going to invoke by the CloudWatch service itself. But now our function name is dispatch logs. I can go to here and then search for fib, and this is the dispatch logs. And here you can search for the log format. I'll just use other, right? I anyway have the the filter pattern. Now I can actually test with some of my data. Let me choose one of my latest stream and actually test whether these patterns filter my data. If I do test pattern, I can see it has like filtered out properly one of my log messages, which I know, okay, this will work for all the message events as well. Then I'll click start streaming. So what happens if I click start streaming? Whenever a log is recorded, it's going to publish it if and only if that matches with the filter. Metrics filter, it will wait until the metrics threshold is exceeded, right? but I'm using subscription filter for easiness here. All right, so so what happens in this Lambda function, guys? So in this Lambda functions, once I dispatch Lambda function, once I got the payload, and then I'm going to send an email. Because I don't want my customer to call me. I would like to get me an email. So I'm using this service called SES, simple email service. I'll require it, and also I'm using AWS DK here. And then I'll get the data, the latest data from the filter, and pass it to this get email content generation, because this is, although it's kind of a large file, is nothing but having some HTML properly to make it look nice in the email. One thing I want to get your attention on is the to address. So when you're sending the email, I can specify who I want to send it, right? And I created a new email for this session particularly, and I whitelisted in AWS, and then I added it here. So if I have deployed it properly, then if I come here and let's say do an invoke, which invoke an error, I should get an email. So I have opened my email. Let's see, moment of truth. There you go. So I got there, sorry, email. If I now open this message is there because I didn't, whitelist the domain and all that, but it's fine. But here I have a nice readable message that I get, that gets to me, right? I get the application logs, the critical stage is dev, this is the IP, this is the URL path, this is the get, and this is the error message, right? The number must be greater than less than or equal to 40. And also I can get the call stack. The number must be this thing, and this is where the file, and this is the line number, and then I can easily get to it. And if this is not intentional, if this is kind of a breaking change that was introduced after a new release, then I can take a prompt action. So by this time, guys, customer has not even made a complaint, because as soon as this error occurred, we get an email. So I can easily do a quick fix before customer, customer's customer. Let's say you are building application to a ISV. So his customer, before coming into ISV and he comes back to you, you can actually make a fix for this. Okay, so this is real time as you have seen it, which is really good. Okay, so that's mainly step number 5. So we talked about subscription filters, metrics filters, log streaming, real-time notification. Now step number 6. Let's take one more step forward. Now it's cool that we got an email, which is nice. But emails, usually it's not a place for keeping things recorded, right? Where we can always go back. Of course, we can go back, but it get messed up with other emails and all that. We need one place where we can easily see, let's say in last month or last release, how much errors have we got it, right? And in which sort of modules do we get the errors most? This is really cool. The email is very good for a hot fix, but with some log aggregation and with a proper reporting and monitoring, we can understand, okay, there are some root causes for this happening often, and then we can apply a proper fix. So that's why it's important to have these logs in a centralized place. And we can use CloudWatch, of course, and CloudWatch also has some, some tools like Insight and all that. But the very reason I told you earlier, if you have multiple functions, then they get aggregated into multiple log groups, and it's a hassle to go all that. So that's why it's either very good to stream it to, let's say, Elasticsearch. You guys, I think, familiar with ELK stack, right? Elasticsearch, Logstash, and Kibana. So these three are like goes hand in hand. So Elasticsearch will ingest the logs, and then it will create some Kibana dashboard where we can look at our data with more clarity. And of course, AWS has this managed Elasticsearch service. That since it is managed service, one thing is it's not as configurable as the hosted one, one of our hosted on one. And also, as soon as you create Elasticsearch cluster, you have to pay. I think it's $100 or $150, depending upon the Elasticsearch cluster instances that you use. But there are other services, guys. I mean, that's the thing. I mean, we don't always have to rely upon the services that AWS provide. There are some other good services. That's why I'm going to introduce you to, well, there's something I really liked it, and that is logs.io, which is a really cool one. So here also it provides some managed end-to-end cloud monitoring, and I'm not advocating or anything on this one, but I find it easy to use this one. But yeah, so you can create an account and you get some free tier, trial period, and also the cost is also fair. So that's why I thought of like showing you this service as a way of integrating your logs to a different third parties. And of course, you can use any other managed services or any other third-party tools that you like. The thing is, it's the same, right? So in step number 6, let me quickly change it to that. Check out. Oops. And check out step 6. Okay, right. Now I did a couple of changes, guys. First and foremost, I log into this one, and then in the settings, there's this something called log integration token. If I go to tokens, manage tokens, there's this data shipping tokens, right? I need this token to ship data to this platform. So I get this token and I added it as an environment variable to my Lambda function, as you can see. Log.io token, that's all I need, right? And then in the dispatch function, I did a minor change. So the email generation happened as it is because I don't want to like take out the email. And after sending the email, then I am logging in logs.io. So there's this logger function which I required from the which I require from the logs. This is the node package that they provide, the logs.io, and I got it, and then I configure it with my log.io token, and I set the type to critical, right? So that I can easily see, okay, this is the critical log that I report. And I use this same function to logs.log, and that's it basically, and that's going to create the logs. And I couldn't do a Sls deploy. And also, this is the place I'm not going to wait until it is going to publish some data into the logs.io, because it's going to take a little bit of time. As I already mentioned, these are asynchronous things, and this account is a free account. So anyway, the priority level is low. So it takes a little bit of time. But what I want to show you is, as soon as now, if I do any, let's say, 100 or some string values, then I get the email as is, right? I should get the email. Plus, it should index. I got the email. Plus, it should index it in the logs.io. So in logs.io, we have this Kibana dashboard. If I do a refresh, yeah, it's not there. So what I will do is, before this session, a few hours ago, I did some ingestion. So you can see there's a 5 hits, and underneath it, I can see the context, right? You see, I am logging the same context I have in that dispatch log function. You see, I have the path, source IP, stage, message, and all that. Now, the best part is, from whatever the other Lambda function, I can do the same thing. And then I have one place where I can inspect all my logs. How can I do that? So there's this small plus button. Let's say I want to get all the critical logs. So I just add the plus button here, and that is going to add this critical type. Then I see, okay, there are three of these. So I can click and drill down to this, and I can actually see what are these 3. And I can then further drill down into this and actually see where they occur and all that, right? So this really helps me to understand more about my logs. And on top of that, guys, this tool, we can create some dashboards, right? These are like real-time entries, but I can go ahead and create some dashboards. Now, these are like common functions for lot of log management. If you use Splunk, so they have these, right? and I can like create reports, and also I can even link it with other third-party services. For example, I can link it with Slack. So as soon as some critical thing happens, then I get a notification to the Slack. And of course, we can do all these things in AWS platform itself, but there are other services. That's what I want to show you. So right, so hope this is also clear. So let me do a git checkout. Right. So let me go into the last step. So that is the introduction to DevOps Guru. Now, so far, guys, what we have done is we actually observe, we actually maybe custom logged different functions, right? And then we added several filters manually, and then we created subscription filters or metric filters, and then accordingly either we push it to third-party services or we send emails and so on, which is all good. But in AWS, as any other cloud providers, there are so many matrices. Now, for example, if I just go to a Lambda function, now this is the generate a Lambda function, and if I just go to, let's say, code, right, and the code, yeah, monitor section, right, you can see I get, by default, I get, oh, I got signed out. It's fine. I get a lot of, matrices, that some lot of inbuilt alarms or matrices. Wait until they get loaded. You see now these are by default. I can see the invocation rates, right? I can see how the duration in each Lambda functions, right? Then for all these requests, I can see if there's any throttles, asynchronous deliveries, failures, concurrent executions, right? All these things I can monitor it. And I can easily, expand one of these matrices and add an alarm on it. For example, if I want to keep my duration of the Lambda function in a certain range, I can have a threshold for that range and then create an alarm. And as soon as it goes above that threshold, the alarm goes off and then we get a notification. But this is just Lambda itself, guys. But in our application, we have API gateway. So API gateway is also having so many matrices. Now, there are so many matrices that we really need to go over and really observe. And that's going to take some time. That's where this Amazon DevOps Guru was introduced to automatically detect operational issues, guys. And it is doing through ML-powered insight. So there's this machine learning model that is trained for a long time through that was already using in AWS. And through that, for example, what we need to do is for this machine learning model, we need to send the application infrastructure layout for us. For example, now our application, as I earlier showed you, we have a CloudFormation template, right? So this CloudFormation template includes all the services that we use in our application. So in this case, it's only API gateway and Lambda. But imagine a production application which has bunch of these services. So in Amazon DevOps Guru, we just have to feed it the application configuration file, which includes all the services, and then it is wise enough to understand what are the alarms that matters to this application, right? So it's going to reduce the noise because there are so many alarms. So it's going to really hand pick the alarms that we really need to concern about, and we don't have to do anything really. So it's a ML powered. You don't have to have machine learning knowledge or anything. Just about like enabling this service. And they said the efficacy rate of this service is 80%. So just imagine, just by using this service, you get 80% of the operation insight for your application, like tailor-made to your application, just by giving your CloudFormation stack, right? And now let me show you how to do that. And this step, I think, let me increase the font size here. So you see, I just have to feed in the CloudFormation stack. Oh, I can just send the entire AWS account. So the DevOps Guru will observe the entire AWS account, or I can just feed in the CloudFormation stack. Now, how the DevOps Guru is priced is the number of analyses. So if you give your entire AWS account, your price will be high. But if it is only the CloudFormation stack, you can actually see how much it's going to cost you even prior, and then it will only suggest you the things that for your application only, right? And this is the interesting part. See, it automatically, you don't have to do anything manual, right? Automatically ingest operational data from Amazon CloudWatch, AWS Config, AWS CloudTrail, and AWS X-Ray. Now, CloudWatch you already know. Config is whatever the resource change that you do in AWS, it gets recorded in this AWS service called AWS Config. And you can play back all these changes that you or your teammates or your application has done. And the CloudTrail is again, it logs all the API events, because in AWS, even though we click stuff and do all the stuff in UI, everything is API code. All those API code get recorded in CloudTrail. And that information is also getting ingested. And AWS X-Ray, like if you have a distributed application, X-Ray service is really useful to identify different latencies between your components and so on. So all that's logged get logged in to Amazon DevOps Guru, and then it keeps continuously analyze these things against the machine learning model, and you can see models informed by years of Amazon.com. So this was like trained with Amazon.com site itself, and so it is well trained, as they say, and with that it's going to analyze all that, and it's going to suggest us what are the recommendations for your application and what are the related events that you need to be focused about. What are different matrices? For example, this really helps you to get that proactive information even something bad happens to your application. Now, yeah, so it's correlate to the anomalies, and you can like find out the recommendations and all that. And then the best part is this information can be then ingested to third-party systems. For example, one of the things actually I am planning to do in my project, in one of my projects, is use this OpsGenie. Now, this OpsGenie is on-call alert management system to keep. This is about like basically alert management, and this is the Atlassian product, popular one. So I mean, it has direct integration to it. So it's a very easy way of doing this integration with OpsGenie. So I'm going to try out after, and then because this service is still not in general availability though, but it's available in some regions in AWS. But what I want to show you is a quick demo, although you might not see much insight from OpsGenie, but I want to show you one thing that this come in handy in our application context. Now imagine right now, where am I? I'm at step number 6, I guess. Let's go this. Right. So it's step number 7. Well, actually I haven't done much, right? So what I did is I went to the serverless YAML configuration, and I reserved the concurrency of my Lambda function to 1. So what does this mean? That means at any point in time, how many requests have been received through the users to our Lambda function, it will have only one instance running all the time, because I reserved its concurrency to 1. Usually a Lambda function, a particular account get 1000 concurrency allocated for an account. You can of course put a service request and increase it. And at 1000 concurrency for Lambda function get load balanced and allocated to all the Lambda functions in your account. But if you want to reserve the concurrency for good reasons, because there are some reasons, if you want to consume some messages from a SQS or queue, then you have to make sure these things are properly error handled and all that. For some reasons, you might need to reserve the concurrency. So in this case, let's imagine developer want to like reserve the concurrency for this particular Lambda function 1, right? And in the meantime, I'll do a Sls Deploy. So that means even though we get multiple requests, those, let's say I get 4 in parallel requests. Now the first request will be served. Until first one is served, the other 3 requests will be throttled, right? Maybe the developer is not aware that this application is used in concurrency, has this number of concurrency. So probably like for some reason he might have added it for some good reason. But with Opsgenie, we can actually get some insight about, okay, you have done a release on this particular date, production release, and on that production release, you set the reserved concurrency to 1. And that's why you are getting these throttles in your application. You can get such insight. These are some proactive insight, which is really comes in handy when it comes to our application operations. I'm not sure if I get it because since it is machine learning and it takes some time to evaluate your cloud formation. So, but I'll show you how to do that. So you guys can try out if you're interested. You can quickly go to services and search for AWS DevOps. Oh, I just said DevOps Guru. I think I'm almost with the time, but let me take a few more minutes and conclude it. It's going to take some time. Yeah, so you can click get started, right? And when you click get started, oh, very nice. So I previously enabled it. So they have analyzed my application. So apparently it has not found any issues because I think the latest version I did not add that reserved concurrency. But usually I get some information about it. So how would you edit? Like you can go to the settings section and you can associate your CloudFormation stacks. There we go. So I associate this fib generator dev CloudFormation stack, and you can click click manage, and you can either add one or more CloudFormation stack, or you can get your entire AWS account to analyzed by this service, and you get very good results, and you are charged based off this analysis, number of analysis. Yeah, for me it's healthy because I just did the deployment. After an hour or so, I should see some insight. So this is the cool part. So insight, I get the reactive insight, and then I get the proactive insight. The proactive insights are the one yet application haven't come across, but the possible issues, and reactive ones, of course, things that happens, and it will identify it. Okay, guys, so these are the things I wanted to share with you. And finally, let's share a couple of tips on the other important topics, right? And I already mentioned about the X-ray service. If you have a distributed application, it's not a serverless per se, like completely serverless service, but containerized environments, so many containers, maybe Kubernetes or something, orchestration, okay, all those containers. Then you can use this service called AWS X-ray to get the latencies and context passed around these components. And you can use correlation IDs. Is again very useful when it comes to distributed application. You can pass the kind of unique ID across the services that this request, one of the user requests, travels through. And finally, you can make good insight, get a good insight about these events, because once you have the same correlation ID part of these different events, then you can log it into a centralized log location, just like logs.io or wherever it is. Then you can search by its correlation ID, and then you can filter very good details from that. And maybe another sort of events that is very helpful is the security events, right? We haven't talked about DevSecOps part, right? Security is also very important. And AWS has this security hub, which is a very good service. And it is also very less configurable. I mean, you don't have to do much. You can configure it very quickly. And that is using several other services underneath it: GuardDuty, AWS Config, CloudTrails. And through the security hub, guys, you can actually, let's say there's a breach in your system. You can actually analyze at what point this breach occurs, how this happens, what are the IP addresses that try to do the breach, and you can get the full landscape about the breach. Like it is a very comprehensive service, which I would recommend you to observe it if you want to like have some monitoring and monitoring on the application as well. All right, so that's it, guys. Thank you very much. I know I took some more time, but if you guys have any questions, let me know. Okay, I'll share the links with you if you are interested. So I'll share with Vihanga, so he will share with you all. And thanks, guys. Have yourself a nice evening.
So I would like to thank Manoj for accepting our invitation and taking a bit of time from his busy schedule and sharing knowledge with all of us. You can check out his YouTube channel, Enly Academy, to find more interesting videos on AWS. So we will drop that link in the chat as well. Thank you so much, Manoj. So in case you missed the beginning or you won't refer to this session, we will be adding it to YouTube in the coming few days. So it will be added to the same playlist to which we have shared the link with you in the chat. We are planning to have our next session on infrastructure automation with cloud development kit. So stay tuned for that. That is all for this session, guys. So thank you, everyone. Hoping to see you all in the next session. Till then, take care and stay safe.
Thanks, Vihanga. See you guys.